Hey guys, so these are the Math 1 notes for Chapter 3, Section 2. We are still dealing with transformations, and I'm going to try to go kind of quick. I think if you need to write stuff down, which you should be writing down pretty much exactly what I write down, and maybe more if that helps you. But you have the opportunity, if I go quick, to stop the tape and catch up with your writing and then start the video up again, right? So here we go. Let's see. So we are doing a little exercise here to start. We're going to do a reflection, and we talked about doing reflections in the last section. So I am going to do that here. I am going to do a reflection across line N and then across line P. So first I'm reflecting this triangle ABC across N. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And here I have A prime. And then B would be 1, 2, 3. 1, 2, 3. And here would be B prime. And then C is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And here is C prime. And so my triangle, that's a terrible line, looks like that. And again, I like to shade in lightly with my pencil the image, right? So now I'm going to take triangle A prime, B prime, C prime, which is the middle one, and I'm going to go across line P. So A prime would go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And this would be A double prime, right? Double prime for the second reflection. And C would be 1, 2, 3, 1, 2, 3. C double prime. And B would be let's see, 8, 9, 10, 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And here would be B double prime. And when I draw it, it looks something like that, right? All right, I want to look at what we've actually done here. So what happened to get from triangle ABC to A double prime, B double prime, C double prime? Essentially, what happened to go from here to here, right? Well, that thing is actually called a translation. And I'm going to talk about a translation in a minute. Well, I guess I could do it now. I need to do this, sorry. When you do two reflections across parallel lines, the result is a translation that is 2 times the distance between the lines. Now, you might remember from last year that a translation is really just a slide. It is when you take the figure and you slide it across the graph. You don't rotate it. You don't turn it. You don't reflect it. It's like you put your finger on it and you just push it across the graph. And you can notice that these two lines that are parallel to each other are 14 spots apart. And I think based on this 2 times, that this triangle must have slid, right? That's all it is. It's a slide. It must have slid 28 spots. And if you count the distance from B to B double prime, I think you would find that it is 28 spots. And there's one more thing I'd like to point out here, and that is about a reflection. Reflection changes the orientation. So what is the orientation? The orientation is the way you name a shape. My original triangle, the black one, has, it is called triangle ABC, right? And the ABC goes clockwise, right? When you look at the ABC, the A, then the B, then the C is going clockwise around the triangle. But then I reflected it across line N, right? I reflected across line N and I got this red triangle. And the red triangle has the ABC going the opposite direction, right? From A to B is going counterclockwise. So that is what it means by the orientation has changed. It's gone from clockwise to counterclockwise. And you see when I went from the red one to the blue one, the orientation changed back, so it's going clockwise again. Every time, well, we're going to look at that. Let's see. In a reflection, I'm right here. In a reflection, every time you do a reflection, the orientation changes. So you should know what that means by the orientation changes. A translation, just sliding a shape from its original position, is called a translation. I hope you remember that from last year some. A translation has the same orientation as the original figure. In a translation, the original figure has not been turned or flipped, it just slides. All right, so that's 2 reflections across parallel lines. Now we're going to look at 2 reflections across lines that are not parallel, right? These 2 lines intersect at the point P right here. And I'm going to reflect this triangle across, first I'm going to go across V, then I'm going to go across W. So first I will go across V. I'll go 1, 2, 3, 1, 2, 3, and here is F prime. And G would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 3, 4, 5, 6, 7, 8, 9, 10, 11. And here would be G prime, and E would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. We ought to be experts at, I think I did something. No, I didn't. I'm good. Experts at reflections at this point, maybe. And so there is my reflection. You can see the orientation changed. And now I'm going to go across the other line. So I'm counting diagonally. 1.5, half and then 1. Here is G prime. And the E prime goes 1, 2, 3, 4. 1, 2, 3, 4. And here is the E double prime, G double prime. And the F goes 1, 2, 3, 4, 5.5. Half, 1, 2, 3, 4, 5. And down here is the F double prime. And when I reconnect those, I get that. All right, this time the lines are not parallel. Is the image a translation? When you go from the black, the original, to the blue one, is it a translation? Well, no, certainly not. Right, this time the original shape has almost gone around in a circle. Notice that it is, well, I'll point that out in a minute. No, it turned, right? It turned, it's kind of going around, well, it's going around this point right here, point P. Like the ice cream cone, if you look at the ice cream cones below, the final image is a rotation. And it is rotating around point P. Let's go ahead and fill in the box and we'll talk about it. When you perform two reflections across intersecting lines, the final image is a rotation of the original. Every rotation has a center of rotation. That is a point that the figures are rotating around. The point that they're rotating around, right? So that center is a point, and if you're doing two reflections, it's the point where the two lines intersect. This was a 90-degree clockwise rotation. Let me show you how it was 90 degrees. Let me go back and show you that. If I take point F and connect it to the center, and I take F double prime and connect it to the center, I have made a 90-degree angle. Think of that purple line as a stick, and that stick is just rotating 90 degrees clockwise, and it's dragging the triangle with it, right? Is it possible to rotate the original triangle counterclockwise and get the same one? Could I go the other direction? Well, I could. I could take this and rotate it all the way around this way. Do you know how many degrees that would be? That would be 270 degrees the other direction, and I would end up in the same spot. So the answer is yes, 270 degrees counterclockwise would equal 90 degrees clockwise. I think that's enough about rotations for the moment. Let me keep going here. Can we take this shape and rotate it 90 degrees clockwise, counterclockwise about point Q? So I want to rotate this way 90 degrees. So my advice is you take each line and you rotate it 90 degrees. I would start with this line right here, and I would make a 90-degree angle, and I'd rotate it here. Let's see, that line is 1, 2, 3, 4, 5, 6 long, so 1, 2, 3, 4, 5. It would end right there. And all I've done is rotate this 90 degrees. So it's gone from a vertical line to a horizontal line. Then I might take this blue line here and rotate it 90 degrees. So it would rotate from a horizontal line up to a vertical line. 1, 2, 3, 4, 1, 2, 3, 4. It would be right here. And at that point, I would probably finish the shape. Now, I know it's tough to see, but I'm going to start going here. So at the end of my red line, I go 2 spots, which would be these 2 spots. And that ends me right there. Then I go 1, 2, 3, 4 spots back. So 1, 2, 3, 4 spots back. those two lines would be matching. Then I go 2 spots up, so 2 spots up, those 2 lines, and then I'm going to meet the blue line in 2 spots. So I meet the blue line in 2 spots. And this is a little bit hard to see, I'm sure. But this red shape matches my original shape, and all I've done is rotate 90 degrees down around point Q. Now that might take a little bit of practice, but again, it's something you should have done last year, maybe. I'm not sure. Well, probably you should have. All right, real quick, I'm trying to get through this. So here I have a diagram that shows an image of triangle ABCD, right? So this is the pre-image, and this is the image, the A prime, B prime, C prime, D prime. It says, look carefully at the correspondence between the vertices, like where is A, where is A prime? Where is B, where is B prime? Can you either rotate or reflect the original square to make the letters correspond as shown? If you reflect, where would the line of reflection be? If you rotate, where would the point of rotation be? Well, here's what I notice. I notice that the A and the B have switched directions. Here they were going clockwise. And over here, when I go from the A to the B, I'm going counterclockwise. So if the orientation has changed, I know this must be a reflection. And the line of reflection is right here. Notice how B is about the same distance as B prime, and from A to the line is about the same distance as A prime, and so is C and D. So this guy is, I know it's a reflection, since the orientation changed. And, we'll just go ahead and call that line M. Line M is the line of reflection. The second one, it says that ABCD is rotated 180 degrees, so it's a rotation. And I am supposed to label the vertices of the image. So this thing is the pre-image, this thing is the image. Where does point A end up when you rotate it 180 degrees? If you just take your paper and you rotate it 180 degrees, so you turn it upside down, you can see where the points will end up. Point A is going to end up all the way over here, and this would be A prime. And point B would end up here, being B prime. And point C would end up here, and point D would end up here. All right. Last one, thank goodness. I'm just going to talk about this for a minute. What is a rigid transformation? So this is just a vocabulary word for you. A rigid transformation is a transformation that does not change any of the measures of the angles or the side lengths. All the measurements stay the same. It really just moves the shape. And all three of these, reflections and rotations and translations, they are all called rigid transformations because they do not change the size or the measurements of the shape. That's what makes them rigid. They're rigid because it does not change the shape. All right, so one more thing here. I want to find a series of transformations. I don't think there's one, although maybe there's one that you could figure out to do it. But I'm going to do it in 2 steps. two transformations that would take ABC to A prime, B prime, C prime. And again, you guys, the first thing I notice is that in the original triangle, ABC is going clockwise, but in the image, A prime, B prime, C prime, it's going counterclockwise. So I know that one of my transformations is going to have to be a reflection. So the first thing I'm going to do is just do a reflection. And to make it simple, I will just reflect across the line x equals 2. So that would look like this. Here's the line x equals 2, a vertical line. The C is going to stay right where it's at and be C prime. The B is going to go 2 spots, so it would be right here, B prime. And the A is going to go 2 spots, right? 1, 2, 1, 2. This would be the A prime. And my new triangle would look like this. Then I simply need to take this triangle, and I need to slide it. I'm going to slide it 2 spots this way and 2 spots this way. I'm going to slide it to the right and down. Let me show you how we would say that. Well, we'll just do it easy today. We're going to translate it to right and 2 down. And if you want to see how to do that the cool way, it would be this. This thing is called a vector. A vector is like an ordered pair, but it's inside these angle things instead of parentheses. And the first number in the vector is telling you left or right, and the second number is telling you up or down. I'm going down, so it's negative, and I'm going to the right, so it's positive. So this would be like my translation vector, and I would take B 2 to the right and down 2. I would take C 2 to the right and down 2. I would take point A 2 to the right and down 2, and I would end up right where I want to be. So this would be my 2 steps that would take the original triangle to the new triangle. That's it. Maybe you have 2 different, in fact, you could have 2 different steps and you could still get there. But one of them would have to be a reflection, all right? We're not doing the 2 questions at the bottom. You're good to go. Good luck.